All right. Let's go over these notes real quick. Again, if you were, or as I said today in class, if you were in class today being Wednesday, then you've already gone over these notes. But of course, you can always go back and rewatch this if you need any help. Also, bear with me. I did accidentally leave my answer key for this set of notes at school, and I'm at home recording this, so I may have to refer back to the answer key that is on my phone. And so if I pause for a second, sorry, just bear with me. I don't have my set of notes that I've actually worked through already myself, so I'm having to refer back to the answer key that I have from Tarleton instead of the one that I worked through. Okay. All right. So we've been going over just simplifying rational expressions. And so 9.2 is solving rational expressions, solving rational equations, which honestly is a lot of the same. It's a lot of the same as far as simplifying it. But it's a lot of the same. It's a lot of the same skills. You're not going to be learning a new skill or anything of that sort. So don't stress about that. Okay. So, on this first example here, just some observations. We're going to fill that part out first. Some observations that we notice. So one thing I do see is that each denominator has, denominator. No, that's not what I want. There we go. Okay. Each denominator has either an X, a 3, or a 9. Okay. And so, in the denominator. Okay. Now, and why is that important? Is because that could make a common denominator. Okay. So remember, and it's because of that minus right there. And the fact that we're solving equations, but we have to have a common denominator, okay? One other thing that I notice is we have two denominators that are in simplest form. So two denominators in simplest form, which means we will factor the other, okay? The other thing is that because there's subtraction, that means we must have an LCD. Okay. Okay, so we must have an LCD. Okay. Okay, so now that we've kind of made those observations, let's go ahead and solve this. So we have, and I'm just going to rewrite it down here to give myself some more room. So 6 over x minus 3 equals 8x squared over, now I am going to go ahead and factor x squared minus 9. And so that's going to factor to x plus 3, x minus 3, okay? And then minus, and then we have the 4x over x plus 3. So we have to find an LCD. So the LCD, because all three of these fractions have either x minus 3 or the x plus 3, I can make my LCD just simply be x minus 3, x plus 3. Okay? So my fraction over here, 6 over x minus 3, the only thing that it lacks, there we go, is x plus 3. So I have to multiply both the top and the bottom by x plus 3. Okay? My second fraction here already has x plus 3, x minus 3, so I don't need to change it. But I do need to multiply my third fraction over here. What I'm missing on it is x minus 3, so I'm going to multiply the top and the bottom by x minus 3. Okay? So once we do that, we're going to go ahead and, distribute here. So we're going to have 6x plus 3. I'm sorry. 6x plus 18, excuse me. Over, and then we're just going to keep this as x plus 3, x minus 3. I'm not going to FOIL that out. Okay? And then, like I said, you're not going to change your second fraction because you already have that common denominator that we were going to form. And then now I just need to take my third, so minus, And I'm going to go ahead and multiply this. So 4x times x gives you 4x squared. And 4x times negative 3 gives you negative 12x. And that's going to be all over x plus 3, x minus 3. Now, as I told them in class, I'm going to put parentheses around these right here. And I will tell you the reason being is because this is going to be like 8x squared minus 4x squared. And then like 0x minus negative 12x. So I want you to remember you're still multiplying, or it's not multiplying, excuse me, subtracting both terms on the top. It's not just the negative 4, or, the 4x squared that's negative, okay? You still have to minus both. Okay, so now this is the thing that, this is where it kind of gets cleaner, if you will, or I don't know, better. Because all three of our denominators are the same, we're going to, and I'm going to make note of this, we're going to ignore the denominators since all are the same. Okay, and so when I say that, what I mean is we are literally going to do, okay, 6x plus 18 equals, now I'm going to combine like terms on my right side, okay, so it's 8x squared minus 4x squared, so that's going to become 4x squared. And then, like I said a while ago, you have like a 0x right here. Well, 0x minus a negative 12x is going to become plus 12x, or positive 12x. Okay. Now, all we're going to do is just solve this equation. Okay. So I need to move it all on to the same side. And so one thing I told them today in class that I think will be helpful, if you have, oh, that is way bigger than I thought it was going to be. Sorry. Let me make that smaller. Here we go. So if you have like an x squared, or I think x is the only letter that we use until we get into the real world application later. But if it has a square, we're automatically going to probably have to do factor by grouping, or, just simply factoring. So I'm going to move the 6x and the 18 to this other side. Okay, and that's just going to be a 0 over here. So I have 4x squared. 12x minus 6x is positive 6x, and then I have the minus 18. Okay. So I need to factor this. And so because I have a leading coefficient that's not a 1, I'm going to take that and I'm going to multiply the end. So 4x squared, negative 18. So 4 times negative 18. Oh, wait. I forgot this in class too. I'm sorry, guys. Hang on just a second. I forgot this step. Because all three of these numbers can be divided by 2, we're actually going to pull a 2 out. And it is going to make our job a lot easier, and our brains work not so hard. So I can divide each one of these coefficients by 2. So when I take 4x squared and I divide it by 2, I get 2x squared. 6x divided by 2 gives me 3x, and then negative 18 divided by 2 gives me negative 9. Okay, so now I'm going to factor this trinomial by grouping. Okay, and so I'm going to leave the 2 kind of, you have it, but it really doesn't matter as far as when you solve it. So it's just going to go away. So I have 2x squared. I take 2 times negative 9. And I know I need to multiply to give me negative 18, okay? But this negative 9 is going to stay. I feel like I wrote that really far over. Okay, so what can be multiplied to give me negative 18? So I could do, negative 18 and 1, 2 and 9, 3 and 6. Okay, one of them obviously has to be negative. And remember, those negative signs, we can just flip which one's negative. So I need to find out, well, which pair can I use to add to give me a positive 3? And so that's going to be this pair here, except the 3 is going to be what's negative, okay? So I'm going to have plus 6x minus 3x, okay? So now I get to do factor by grouping. So I have 2x squared and positive 6x, so the thing that's in common there is 2x. So I'm going to get x plus 3 when I pull out a 2x. And then I have negative 3x and negative 9, so I'm going to pull out a minus 3. Negative 3x divided by negative 3 is just x, and negative 9 divided by negative 3 is positive 3. So my factors are 2x plus 3, or 2x minus 3, hold on, I'm sorry. 2x minus 3 and then x plus 3. Okay, so now we need to go into, well, what are the actual solutions, right? So to do that, you would just take 2x minus 3 equals 0. Okay, add 3 to both sides. So 2x equals 3. You're just solving for x, right? So x equals 3 halves. And you would do the same here. X plus 3 equals 0, so x equals negative 3. Okay, now, and I actually forgot to do this, but we need to go back and talk about it. Remember on our LCD, and we talked about this with simplifying expressions, that you have these things where x cannot equal a certain number. And so if my LCD was x minus 3, that means that, or x minus 3, x plus 3, that means x can't equal 3 or negative 3, okay? And the reason that that is important is because remember down here on our solutions down here at the bottom, there we go. X was either equal to negative 3 or, let me say it that way. It could be both. But it could either be negative 3 and or 3 over 2. But because of my denominator, x minus 3, or x equals negative 3, is an extraneous solution. So the only one that can actually be a solution is the x equals 3 over 2. Okay? And so the extraneous solution, that's going to be because, I'm just going to put because of the domain restriction, which is the x cannot equal. Okay? Okay. All right. Okay, so if you need to pause that to kind of process that part of the lesson, go ahead and do so. I'm going to go ahead and go on to the next problem. Okay? All right, so we have x plus 5 over 2, x squared minus 2x minus 1 equals 1 over x squared minus 2x. So our LCD, is going to be x squared minus 2x, okay? Now, because in order to find what our domain restriction would be, we would need to factor this. So that really is just going to be x times x minus 2, which means that x cannot equal 0 or 2. Okay, we cannot have 0 or 2 be our x value on this one, okay? So just pulling down our equation, x plus 5 over x squared minus 2x minus 1 equals 1 over x squared minus 2x, okay? So now this one, it's not that bad as far as what would be what you need to multiply, to get the same LCD, right? We're just going to multiply this by x squared minus 2x over x squared minus 2x, right? Well, obviously, 1 times anything is just itself. So we're going to get x plus 5 over x squared minus 2x minus x squared minus 2x over x squared minus 2x equals 1 over x squared minus 2x. Okay, so I know that sounds like a lot. It's a lot of x squared minus 2x's. However, once you get to this point, remember that because all 3 of our denominators are the same, we now get to just completely ignore our denominators. So we have x plus 5 minus x squared. Now minus a negative 2x is going to be a plus 2x, and it equals 1. Okay, so just combining like terms, I really only have 1 right now that I'm going to combine. So I have negative x squared. X plus 2x is going to give me 3x. And then I have plus 5 equals 1. I need this 1 over here to be a 0. So I'm going to subtract 1 and subtract 1. So negative x squared plus 3x equals 4. Okay. Now, we do have a number in front of x. Oh, wait. I just realized I miswrote something. Plus. Negative x squared plus 3x plus 4 equals 0. Sorry. I'll try to stop making so many mistakes. But because we have a coefficient that is not 1, a leading coefficient, I'm going to need to do the negative 1 times the 4. So we have negative x squared and positive 4. Well, negative 1 times 4 gives me negative 4. And so my factors of -4 can be -4 and 1 or 4 and -1. And so the pairs, and obviously I could have done -2 and 2. All right, but the pairs that I have that equal, when I add together that give me 3x was going to be 4 and -1. So I'm going to go ahead and put my -x plus 4x, okay? And then I'm going to factor by grouping here. So the thing that's in common between -x squared and -x is going to be obviously -x. So when I take -x squared divided by -x, I just get x. And -x divided by -x gives me a positive 1. The thing in common between 4x and 4 is just 4. So 4x divided by 4 gives me x, and 4 divided by 4 gives me 1. So that means that my factors are -x plus 4 and positive x plus 1. Okay? So to find my solutions, I'm going to take -x plus 4 and put that equal to 0. And that's going to be -x equals -4. Divide by a -1 there, and you get x equals 4. I'm doing this one over here. X plus 1 equals 0. Minus 1 minus 1. So that means x equals -1. Now refer back to what your domain restriction was. It said that x couldn't equal 0 or 2. So because neither one of these solutions are 0 or 2, those would be your solutions there. Okay. Okay. Again, pause. Go ahead and pause the video. I'm going to go ahead and go on. If you need any more time on that one, go ahead and pause it. All right. Moving right along. Okay. So this next problem here, my denominators are x squared, x, and 2x. Okay. So I know that I can do my LCD being 2x squared. So that means that x cannot equal 0. Okay, so when I write this one out in just a second, I will tell you I'm going to give myself some room so that way I can show what I need to multiply by in order to get the LCD. So I have, okay, x squared minus x minus 6 all over x squared. In order to get my LCD on this one, I'm going to need to multiply by a 2 on the top. There we go. And the bottom. Then I just have minus 2x plus 12 over x. Well, in order to get 2x squared as my denominator, I need to multiply this one by 2x over 2x. All right, and that's going to equal x minus 6 over 2x. And in order to get 2x to be 2x squared, I need to multiply it by x over x. Okay? So again, I'm going to go ahead and distribute this. So it's going to give me 2x squared minus 2x minus 12. And then distributing my green term here. 2x times 2x gives me 4x squared. 2x times 12 gives me 24x. Oh, I'm sorry. My denominator now is 2x squared. Okay. X times x gives me x squared, and 6 times x gives me 6x. Okay. So I do have common denominators now, so I can just ignore them. Don't worry about the denominators, and I'm just going to use my numerators. So I have 2x squared minus 2x minus 12 minus 4x squared minus 24x, correct? Yep. And it equals x squared minus 6x, okay? Now, before I move the x squared minus 6x to the other side, I am going to go ahead and combine like terms just because I think it'll clean it up and make it easier. So I have 2x squared minus 4x squared, so that's going to be negative 2x squared. I have negative 2x and negative 24x. That's going to give me negative 26x. And then I'm just left with negative 12. And again, that equals x squared minus 6x. So I'm going to go ahead and move these both to the other side. Okay, so I'm going to get negative 3x squared minus 20x minus 12. Now, there's not a number that 3, negative 20, and negative 3, negative 20, and negative 12 can all go into, so we're not going to simplify that. We did on the last one where we pulled out, or not the last one, the one on the front page where we pulled out the 2. Excuse me. So, because there's a leading coefficient that's not a 1, I need to go ahead and take negative 3 times negative 12, and that gives me positive 36. So I know I have negative 3x squared and negative 12 at the end. But I need to see, well, what can multiply to give me 36? So I can obviously do 36 and 1, 2 and 18, 3 and 12. Okay, 12. But somehow I need to add to give me a negative 20. So I could do negative 18 and negative 2. Okay, so I'm going to use negative 18x and then negative 2x. And then do factor by grouping. So in common between negative 3x squared and negative 18x is the negative 3x. So negative 3x squared divided by negative 3x gives me x. And negative 18x divided by negative 3x gives me a positive 6. Negative 2x and negative 12 have a negative 2 in common. And so whenever I pull out a negative 2, I am left with a x plus 6. And then, obviously, the last thing is just, or not the last thing, but as far as the factoring, we just need to write our factors. And so now we need to see what our solutions are. So again, I'm just going to take the first factor, negative 3x minus 2, put it equal to 0. So I get negative 3x equals 2 divided by negative 3. X equals negative 2 over 3. And then I have x plus 6 equals 0, minus 6 minus 6. X equals negative 6. So whenever I get to this point, I need to go back and check my domain restriction. And the only thing that x could not be equal to is 0. Okay? So because neither one of these are 0, that means that these two would be solutions. All right. Now, I will tell you some good news on number 3. On number 3, this one's actually fairly simple. Okay, there's not going to be a whole lot of writing on this one, much like the last two. So this one, there will be, there won't be a lot of writing. It's a lot easier. So, but I do see I have x, 3x, and then a whole of 1. So then, because of that, I know my LCD has to be 3x squared. No, 3x, excuse me, I'm sorry. So my LCD has to be 3x. So because I have room on this one, I'm actually not going to rewrite this equation. So to get this first fraction to have a denominator of 3x, I just need to multiply the top and the bottom by 3. Okay. My second fraction already has 3x as a denominator. And then a whole number that I need to have a denominator of 3, I'm just going to multiply, or 3x, I'm just going to multiply the top and the bottom by 3x. Okay. So whenever I do that, 3 times 24 gives me 72. So I have 72 over 3x. And then the 24 over 3x I don't have to change because it already has a least common denominator. And then 1 times 3x over 3x gives me 3x over 3x. So again, they do all have the same denominator, so I don't have to worry about those denominators anymore. So now I have 72 plus 24 equals 3x. And I'm sure you can already tell by now, at this point, this is a linear equation. And all we have to do is solve for x. So 72 plus 24 is going to give me 96 equals 3x. And I need to divide by 3. So that means that x is going to equal 32. Now, I do think I forgot to say what x can't equal on our LCD. So whenever your LCD is 3x, that means that x can't equal 0. Well, x didn't equal 0. X equaled 32. So in that case, that would in fact be a solution. Okay. All right. And this one, there is a little bit to this one, but it's not too much. And so this one won't be as bad either. So we have one denominator is x minus 4. The other one is x minus 3. So the simplest LCD that we're going to have here, or the simplest denominator here, is we're just going to say, okay, well, let's just make it x minus 4, x minus 3. Okay? That's just what it is. So I see that over here on my fraction on the left, I'm missing an x minus 3. So I need to multiply both of the top and the bottom by x minus 3. Then on the right side, I have x minus 3 as the denominator already, so I'm missing the x minus 4 part. So I'm going to multiply the top and the bottom by x minus 4. Okay. Now, I'm going to go ahead and multiply out the x minus 3 times x plus 1. So x times x gives me x squared. Negative 3 times x. I'm probably going to do more steps than you need, but I'm just going to do it just in case anybody needs help. Negative 3 times x gives me negative 3x. X times 1 gives me 1x, or just x. And then negative 3 times negative 1 gives me negative 3. So that is going to be x squared minus 2x minus 3 for the numerator. And, I mean, I guess you can say over the x minus 3, x minus 4. We'll talk about that in a second. All right. And so then I move over here to my second fraction. So again, I'm going to multiply this out. So that's going to be x squared plus 2x minus 4x minus 8. So when I combine like terms, I get x squared minus 2x minus 8 all over the x minus 3, x minus 4. Okay. So again, they do have common denominators. So I'm just going to look at my numerator. X squared minus 2x minus 3 equals x squared minus 2x minus 8. I'm actually going to take it a little bit further than I did in class. And just so if anybody that's rewatching it, if they needed kind of some extra steps from here, they can see it. So I'm going to go ahead and take my x squared away from that side. So I get negative 2x minus 3 equals negative 2x minus 8. Okay, you could even say from this point the answer, you may see it already, but I'm going to go one more step. And I'm going to combine my x's. And so that means I would have negative 3 equals negative 8. But is that a true statement? Well, negative 3 does not equal negative 8. And because negative 3 does not equal negative 8, that means that's going to be no solution. Okay? Because the thing I'm about to circle in yellow, whoops, that's what I want. This is not a true statement, and because it is not a true statement, it would be no solution. Okay? All right. We are just rocking and rolling. I hope this is making sense. If it's not, make sure that you come see me. I've told a few of you, those of you that were in class, and then some that have emailed me, we will be testing on Tuesday and Thursday of next week. I will not be there on Monday, unfortunately, but, and I hate to do that, especially the day before a test, but that's just the way it works out. But if you need to come in on Tuesday, just get with me. I know several of you have band during third period whenever I have a conference period, but if you need to come in during a different day or different time, just get with me, okay? I can make it work if I need to answer any questions for you, okay? All right, so on this real application, okay, so we have a herd of antelopes, that were released onto state game lands. And it says that the expected population of the herd is modeled by this equation, where T is the time in years since the antelope were released, right? So it says, well, when will the population reach 100 antelopes? So that's when it is going to be equal to 100, okay? So I'm going to use this equation they gave us, and I'm going to put it equal to 100. So I'm going to say, okay, well, 100 equals, and then 15 plus 42t over 1 plus 0.15t, okay? Now, just as we've been doing on the other two, or the previous two pages, we do have to have a least common denominator. So least common denominator is going to be that denominator they had there, okay? It's going to be the 1 plus 0.15t, okay? Well, just as we did on one of the previous problems when there was a whole number of 1, since we're trying to make the 100 have a LCD of, or a denominator of 1 plus 0.15t, I'm going to multiply. I'm going to use a different color so you can see what I'm doing here. I'm going to multiply the top and the bottom by 1 plus 0.15t. Okay. So 1 times, okay, there we go. Sorry, I was kind of lost there. 1 times 100, obviously, is going to be 100. And then 0.15 t times 100 is going to be 15 or plus 15t. And it's still all going to be over 1 plus 0.15t. And it equals, and I'm not having to change the second equation because it already has the denominator that I need it to have. Okay? So just as we've done in the previous problems, once you have the common denominator, ignore it. Okay? It doesn't matter anymore. I'm drawing an arrow. By the way, that's what that is. All right, so that now is just going to be 100 minus 15t, or plus 15t, excuse me, equals 15 plus 42t. Okay? And so what I need to do now is I just need to solve this for t. It's much like the third problem on the previous page, where we're just going to combine these like terms and solve. All right, so I'm going to subtract 15t to both sides. And I get 100 equals 15 plus 27t minus 15. So 85 equals 27t. And the last thing I need to do is divide. Whoa, it looks like a 3. Divide by 27. So that means that time, and this is the way she wrote it on the answer key when she worked out the notes. So I suggest that you do the same. That means that t is approximately, and that's what I'm talking about when I say do the same, okay? Don't try to just say this equals 3, okay? But it's approximately 3.148 years. I think that in class we abbreviated it to 3.15, okay? But it's approximately 3.148 years when the antelope herd will now be at 100, okay? All right. So the next question, it says, well, find the initial number of the herd. So as a reminder, it tells you t is time in years. And so when we talk about initial, we're talking about the beginning. How much did they start with, right? So think to yourself for a second, well, what would time be? So time is going to equal 0, right? It's at the beginning. No time has passed. This is what they've started with. So there hasn't been any years past. And so what we're going to do, and this one actually is extremely simple. We're just going to use our original, or the original equation they gave us. 15 plus 42t over 1 plus 0.15t. Well, as we just said, time is 0 because it's initial. So that's going to be 15 plus 42 times 0. Over 1 plus 0.15 times 0. 0. Now, I know, and I know that y'all know this too, anything times 0 is 0, so that means that we have 15 over 1, which means the initial herd was 15 antelope. Okay? So that's how many were in the herd to begin with whenever they very first had the herd, and they started, they released these antelope onto the state game lands. Okay. All right. And so then the last problem here that we need to go over, and we're going to have to remember what we just found on this last question, because it says, well, how long is it going to take for the herd to double in size? Okay. So ask yourself, or remind yourself, if you will, what was the initial? Okay, the initial was 15 antelope. So if we're doubling it in size, that means that it needs to be 30 antelope, right? Because we started with 15 and it's wanting to know how long until they can get, they have double, they have 30. So we're going to use our original equation. So 15 plus 42t over 1 plus 0.15t. But this time it's going to be equal to 30. Now, as we've been doing, and as we've been very consistently doing whenever we're solving these equations, we do have to have a common denominator. So much like the first problem on this page, our LCD is going to be the 1 plus 0.15t. So if I have this number 30, and I need it to have a denominator of 1 plus 0.15t, I'm going to multiply the top by 1 plus 0.15t, and the bottom times 1 plus 0.15t. Okay? And so the left equation obviously is going to stay the same. So we get 15 plus 42t over 1 plus 0.15t. Now 30 times 1 gives me 30. 30 times 0.15, if I remember right, gives me 4.5. Yep, sorry, 4.5. Okay, so 4.5 t, and it's all over 1 plus 0.15 t. Okay, and so the last thing that I need to do here, ignore those denominators. They're the same. They don't matter anymore. We have common denominators. So now I'm just going to make this 15 plus 42t equals 30. Oh, I'm running out of paper over here. 30 plus 4.5t. Okay. And just like we did on the first question on this problem, we're just going to solve it for t. All right. So I'm going to subtract 4.5t from both sides. All right. And I get 15 plus 37.5t, and it equals 30. And then I need to move the 15 to the other side, so I'm going to subtract 15. So I get 37.5t equals 15. And the last thing to do would just be to divide by 37.5. So that means that t equals, and it is an equal, okay? It's not an approximate on this one. T is equal to 0.4, and make sure you put years, okay? I have not looked at the 9.2 college homework yet, but I do know this is exactly how she has it on her end, and so I want to make sure that make sure you put the years, okay? Don't forget that. And make sure you're reading her questions to see if you need to do that on your homeworks, okay? All right, so just to recap on the important announcements, other than the notes that I've gone over, we will be having a college exam next week. This week was way too crazy, and I hadn't finished covering everything to test this week. Ideally, I could have tested on Friday, but several students will be out with academic UIL, and so that's just not going to work to test on Friday. And so given that, that means that we will be having our Part 1 exam on Tuesday. So on Tuesday, we will have Part 1 exam. And then on Thursday, I will not be there on Thursday, but we will have a strong sub in the class. And I will make sure that he has the code, or she, whichever, has the code ready for y'all to take Part 2 exam on Thursday. And I'm fully aware some of you may be at the track meet on Thursday. And I get it. That's fine. That means that you will then take Part 2 exam on Friday, okay? And I will already schedule that for Friday during 7th period. If anyone knows that they are going to miss any day next week that there is a test, if you have not already, I need you to email me or tell me in person that you are not going to be there so I can ensure to schedule your test when you need to. I am not allowed to extend the deadline for this. I do not want anyone taking a 0 on any part of their exam. So please, please, please communicate to me. It is extremely important that you take care of your business as far as communication, so that way I can take care of my business to help set you up for success. So again, if you're not going to be there on Tuesday or Thursday, please make sure you let me know so that way I can make sure your test is scheduled when it needs to be scheduled to meet that deadline that is, set by Tarleton. Other than that, I don't believe I have any other announcements. Make sure that you're getting 9.2 college homework completed. Those of you that were here yesterday, if you have watched this and you made it till the end, great job for watching this the second time. But make sure you get that 9.2 done tomorrow. And then anyone else that was not here that watched this because you were absent on Wednesday, you will need to make sure that you get 9.2 college homework complete also before your test next week. We will have a work day on Friday. So Thursday, Friday will be a work day in class, as well as Monday of this week and then into next week. So we're looking at the 27th, 28th, and then the 30th, I believe, is the date on Monday. So just make sure you're taking care of business. If you have any questions, feel free to email me and I will get back with you as quickly as I can. But don't expect an email right away because I will be busy with the track meet on Thursday. Okay. Y'all have a great day.